Right, so S3s, here we go. This is our last video to do with statistics, and our last little bit to get you prepared for a little taster of what the National 5 Applications of Maths course looks like. And what this one is we're going to be looking at scattergraphs. So our previous learning is we've done graphs in general, and we've done coordinates. We've probably or possibly done scattergraphs before, but this is a little bit of kind of making sure that we know exactly what we're doing and expressly stating all these things once again, just to as a wee reminder if we've done them before. So our learning intentions. First thing is to know the difference between a line graph and a scatter graph, because they are not the same thing. Certainly not in maths anyway. We know all about best fit lines, how to draw them, and to use them to estimate a result. Know about correlation and the different types of correlation is our last thing. So we should all be able to successfully plot our points on a scatter graph. Most of us should be able to draw an effective best fit line and be able to use it properly. And some of us should be able to use the correct language to describe the correlation between data. So line graphs or scatter graphs, which is which? So this is a line graph. This is sales per day of the week for a shop, for example. So on the bottom we've got days of the week, and up the side we've got hundreds of sales. So the characteristics of a line graph. So each point is plotted and joined dot to dot. So you can see they're all joined one to the next one, Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday as we go along. One of our axes or axis can have non-numerical data. So see along the bottom, it's going Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. It's got our days of the week rather than numbers along the bottom. That's possible for line graphs. And it can be used to analyse trends. So for example, you can see that they sell less at the start of the week here because all the numbers are a little bit lower. We also have a little dip on a Saturday as well, so we can use it as a visualisation for our data to see kind of what's happening as we go along. But we're joining, the big thing with a line graph is that we plot the points and join them dot to dot, and we can have one side that has something that isn't numbers on it. Scatter graphs, however, here we go. We are comparing weight and height. So along the bottom we've got height, along the side we've got weight. So each point is plotted, but we don't join them. And there is a line drawn which approximates the data, but it doesn't join the dots. So you can see our dots and the line don't join together. They're not the same places. So we're not dot to dot joining things up when we're doing a scatter graph. And it is used to compare one type of numerical data to another. So you can see on our graph axis, we've got numbers on one side and numbers on the other one. So height and weight, both numerical or number values. And it can be seen, used to see if there's any relationship between the data. So for example, for this one here, you can see as the height gets more, the weight goes up too. So as height goes up, so does weight. So that's the differences between line graphs and scatter graphs. So big ones, line graphs are dot to dot joined, and scatter graphs are not. So how do we create a scatter graph? When creating a scatter graph, what we need to do, just kind of some tips here. It doesn't usually matter which data you put on which axis. So you could have, for example, if we're going to look at that one, height and weight, we could have swapped those round. It doesn't actually matter. For each axis, you need to make sure you pick a sensible scale, and you don't always need to start at 0 unless it makes sense for your numbers to start at 0. So if we think about that one on the back, go back a PowerPoint, here we go, that should go back. Neither of those start at 0, one starts at 95 and the other one starts at 15. So we're not at any point, there's no 0 on our axis for our graph, for our scatter graph, and that's fairly common when we're doing scatter graphs, so don't try and start at 0 unless you absolutely have to. As you plot each point, it can be sensible to score out from your list or your table of data as you go, just so that you don't miss anything out. That's just a wee tip. And either use a cross or a plus mark to mark each data point, please, not just dots. I know my scatter graph on the last one had dots on it, but it can be quite difficult when you're drawing your best fit line to see the data points, especially if the line and the points intersect, if you just do a dot. So it can be much better to do a cross or a plus, up to you. So let's see what we're doing. So step by step, making a scatter graph. So here we've got two sets of information. So we've got maths scores and physics scores, and we're going to plot them on our scatter graph. So for the first one, we've got a maths score of 56 and a physics score of 62. So if we look along the bottom, I put maths along the bottom. It goes 50, 60, 70, and we've got 5 boxes in between 50 and 60. So we've got 5 boxes to go up 10. So that's telling us each box is 2. So to go to 56, I need to go along 3 boxes, which I've got there with that little blue arrow that's come up. And then when we're there, we're going to have to go from there up to 62. So looking at our physics one, again, I've got 60, and I've got 5 boxes up to 70, so each one is 2. So to go up to 62, I'm just going up 1 box, and then I put a cross where those 2 are. So we're going along to 56 with the maths, up to 62 with the physics. Put a cross there, and as you can see as well, I've scored out on my kind of table the results so that I'm not duplicating it or doing it again or missing anything out as I go. So the next one is 55, 68. So in this case, 55, if it's 2 boxes for each, like 2 for each box, that means I'm going to have to go along 2.5 boxes. And then 68, so I'm going to go up, and that goes in there, and then we score it off. 52, so I'm going along 1 box up to 63, so I'm going up 1.5 and put my cross in. 62, so I'm going to go to 60 and go 1 box further. And then 75, so I'm going to go up to 70 and then up another 2.5 boxes. So that's where we end up. 59, just half a box short of 60, and then up to 72. That one could go up a wee bit, but it's actually alright there. 67, so 60, go 3 boxes up to get 66, then another half, and up to 82. 60 and up to 78, that's one's there. 65 up to 78, that one's there, and then 65 up to 70, that one there. So we just go through and individually plot our points as we go, going along to one number up to the other one, and then marking across where the two kind of meet. So that's how we draw our scatter graphs. So now we need to look about best fit lines. So when we're drawing a best fit line, we need to make sure that we've got a few things going on. So first things first, a best fit line needs to always be drawn using a ruler. I know in this case I'm using a computer, so it's a straight line anyway, but when you're doing these yourselves, it can't just be approximate, you have to use a ruler. The line should be roughly through the middle of our data. It should have a roughly equal number of points above and below the line. The best fit line should not always go through the origin of your graph, and we need to make sure you don't try and force the line through 0, unless, of course, that's where it would naturally go. And when we make an estimate with a best fit line, you have to make sure you've drawn the line in, or you won't get the marks. You can't just estimate without drawing the actual best fit line in to your graph. So best fit lines, which of the following shows a good best fit line? I can't really, as part of this, show you how to draw one, but I can kind of tell you the pitfalls of some of them. So looking at the one on the far left, our first one there, so this is not a good line of best fit, and the reasons being why. So the line's been forced through the origin. So you can see at the bottom left hand side of the graph, it's been forced to kind of go through that 0 mark there, so that's not very good, and that's not what we do with a best fit line. And the other options, there's too many points above the line, so if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 above, and 3 below. So it's not a good best fit line because that's not an even split in terms of how many are above and how many are below. Our second best fit line, so the one in the middle, this is also not a good line of best fit. Reason being, so whilst we do actually have a similar number of data points above and below, so kind of above the line we've got 1, 2, 3, 4, 5, 6, and below we've got 1, 2, 3, 4, 5, 6. So 6 above and 6 below, but what's happening is the slope of the line doesn't actually follow the data, so our line isn't steep enough. We need to tilt the line a little bit more to make it actually join the data as best we can. So we need to make sure not only do we have the same number of points above and below, but that we've got the same slope kind of as our data that we've got. So our last one, this is our good best fit line. And the reason being, the line follows the data. We have 4 points above it, 3 points below it, so that's roughly the same, and we have 6 points that are actually sat exactly on the line, so or kind of touching it a little bit. So that gives us our good best fit line there. So we need to make sure that we're following the kind of information as we go and trying to make it as good a best fit line as we can. So how do we use a best fit line? So we're going to use a best fit line to estimate a value. So we go along to the value that we've been given, and then we're going to go up and across until we meet our best fit line, and then where this is on the other axis is our estimate. So here we've got this graph that we did earlier on. I have drawn a best fit line in. You can see I've got 3 below, 2 above, so that's pretty good, and I've got 4 on the line, so that's a decent best fit line. So if someone got 57% for maths, what could you estimate their physics score to be? So we need to go along on the bottom to 57, and then we go up until we meet our best fit line, and then we can go across to there. So we can see we went along to 56, up to our line, and across. So we can see that when we go across we get to 70, so we can estimate their physics score to be 70. You need to write it down, you can't just draw the arrows on the graph as well. You need to actually communicate it, which is one of the things I was talking a lot about, I think, in the best deals video. Is one of the big things with applications is you need to be communicating your answers properly and writing them down. But this is also the case for National Applied Maths as well. If you've got a scattergraph, which I think can come up, maybe. Can't remember right at this moment in time. Blame the baby brain at the moment. But you need to expressly write what the physics score is as 70%. I know that's the case for National 4 Maths at least. Right, so we've used a best fit line. Last thing we need to talk about is correlation. So scattergraphs are showing the relationship between two different sets of data. So for example, physics scores and math scores, for example, that's the one we had. And we can be kind of descriptive about our graph when we see it. So we have 3 different types of correlation. We have positive correlation, we have negative correlation, and we've got no correlation. So I'm going to show you kind of examples of what these are. So positive correlation is where as one value goes up, so does the other one. So there we go, there's a graph of positive correlation. So the graphs that we were doing there, so the physics and math scores, that's an example of positive correlation. So as we're going across in one axis, as one axis goes up, so does the other one. Examples, like real life examples of positive correlation might be as the temperature goes up, the number of ice cream sales is going to go up. So the warmer days, you're going to sell lots of ice cream. So there's quite a few things where correlation happens. And positive correlation is quite common. Negative correlation, what happens there is one value goes up, the other one decreases. So this is, instead of our going up from left to right, we're going down from left to right. So this could, examples of this, I don't know, say if we're still talking about sales of things, say maybe it's hot chocolate. So as the temperature goes up, the sales of hot chocolate are going to go down. Less people are going to want to buy a hot drink on a warm day. So cold days, lots of people buying the hot drinks, that's the kind of like left-hand side of the graph. And as we go down, as the temperature goes up, the number of sales of that things go down. And then we have no correlation, which is there is no relationship at all, and which is where the data is totally random, and that looks like this. Just every dot's all over the place. Nothing you can do to make it make any sense. No line, no curve, no anything that's kind of going on. So one of the examples I've kind of seen for this is how far someone lives away from school, and how well they do art. If you think about it, those two things have got nothing to do with each other at all. So there's going to be absolutely no correlation whatsoever when we plot our points on a scattergraph. Right, so the other thing we need to know about correlation is that it can be weak or it can be strong. So the positive and negative correlation ones there, I've got are strong ones, but weak correlation is that all our dots are quite far spread out from the line that our best fit line that we're drawing. And then strong correlation is everything's really close to the line for their best fit. So when we're talking about correlation, if you're asked, you need to describe it as either weak or strong, and then positive or negative, and you can't have weak or strong, no correlation. It's just no correlation, so there's kind of 5 options. We can have weak positive correlation, strong positive correlation, weak negative correlation, strong negative correlation, or no correlation. So it's just based on looking at the graph and seeing, is it close to my line of best fit or far away? And then is one going up while the other one goes up, or is one going down while the other one goes up, or is it all completely random, just scattered all over the place with no sense of any making sense at all? Right, so that is us for Scattergraphs. There's quite a lot of worksheets and things I think for you for this one. So that's it for your kind of little intro to some of the work that is part of the National 5 Applications of Maths course. Same as every other video, if you've got any questions, either leave a comment in the video, or you can ask your class teacher on your Google Classroom. And I hope that's given you a little insight into how the Applications Maths course works, and it's given you a little bit of an idea kind of how it's that little bit different from the maths course rather than which is what we've been focused on mostly up to now. So thank you very much for watching, and I hope that's been helpful.